Hi guys, in this video I'm going to be talking about section 5.1, transformations with quadratic functions. And so this should actually look really familiar to you. We've already worked with transformations quite a bit, but first we're just going to define what is a quadratic function. So it is any function where the degree is 2. So that means the highest exponent is always squared. So if it involves any form of x squared, it is a quadratic if that's the highest exponent. And some characteristic that all quadratics have is something called the second difference is constant. So I'm going to look at the differences in y here. So in this one, I'm going up by 3. And then this, up by 3, sorry. From 0 to 1, I'm going up by 1. The next one, from 1 to 4, I'm going up by 3. And then up by 5. And then up by 7. So in a line, right, linear, these would all be the same. Our first differences are constant. Well, now if I look at the change in the change, right, the change from 1 to 3 is 2. From 3 to 5 is also 2. And from 5 to 7 is also 2. So this is called the first difference. This is called the second difference. So for quadratics, the second difference is always the same. Okay, so we have a couple different forms we can see it in. This is called standard form, okay? This one is called vertex form, and this one is really helpful when we are trying to graph using transformations. So the reason it's called vertex form is because the vertex is always going to be at hk, so whatever these numbers are, that is going to be the vertex. And then a, we know, is a vertical stretch. So let's first talk about the parent function. So y equals x squared. All right, well, we kind of already know what this looks like, but I'm just going to give you guys the reminder. So if I do, let's actually do, yeah, we'll put those. All right, so we're squaring these x's. So -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. So we see kind of those repeating y's. So we have 0, 0, 1, 1, 2, 4, -1, 1, -2, 4. So all of our quadratics are based off of this parent function. All right, so one thing that they have in common, you guys, is that change of 1, 3, and then 5. Sorry, I should have put maybe one more point on there. -3 and 3. So if I go up 1 and over 1, and then up 3 over 1, then up 5 over 1. So quadratics have that constant second difference of 2. So each vertical change is going up by 2 more than it did the previous time. So that is kind of an easy way to get some more points. Okay, so remember, things in the parentheses are a horizontal change opposite of what we would think. So this one is moving left 3 and then up 1. Adding or subtracting outside the parentheses is a vertical change. So I'm just going to start with the vertex 0, 0. So that moves left 3, 1, 2, 3, and up 1. So my vertex is at the point -3, 1. So we can actually get that just from looking at this equation. It's opposite of the x, right? So it's -3 and then +1. So that's always where the vertex is going to be. Now to get the rest of the points, I could also move them left 3 and up 1, or I can use that pattern of 1, 3, 5. So up 1 over 1, now up 3 over 1, and then up 5 over 1. And I usually just do the up 1 and over 1 and up 3 over 1 because kind of standardly for our graph, you guys, will ask you to come up with 5 accurate points. So by doing the 1 and the 3 and then reflecting them, you have plenty. Okay, this one is going to move right 2 and down 1. So my vertex is going to be a +2, -1. So +2, -1 is the vertex. Get my other points, I'm going to use that 1, 3 pattern. So up 1 over 1, and then up 3 over 1. This one I do have room to go up 5 over 1, so I'm going to go ahead and do it. All right, and then reflect those 2 points, 3 points. All right, and then we have our graph. So this one is just using those transformations, but then also using that pattern in the vertical changes to get more points. Okay, this one I have a -4 being multiplied. So what this one has, it is a reflect over the x-axis and a vertical stretch by a factor of 4. So since there is no adding or subtracting in the parentheses and no adding or subtracting outside the parentheses, the vertex has not moved. There is no left or right transformation, so the vertex is still 0, 0. The reflection now means that my parabola is going to open down, and it has a vertical stretch factor of 4. So here is kind of the pattern. So, right, we have that pattern of 1, 3, 5. We just take A and multiply by those things. So if I put in -4 times 1, 3, 5, I get -4, -12, -20. So the negative is just going to tell me to go down, which is I needed for the reflection anyways. So I'm going to go down 4, 1, 2, 3, 4, and over 1. And then I would go down 12 and over 1. And we're going to be off the grid here, so I might just roughly estimate. This one's going to be nice and skinny. All right. Okay, so there is the graph of -4x squared. Okay, this one, I'm actually going to apply the exponent to both of those. So I'm going to rewrite this as 1/2 squared is 1 squared, which is 1. 2 squared is 4. So that's another way to think about this one. So what this one is, again, no left or right. So the vertex is still 0, 0. Okay. And then this one has a factor of 1/4 stretch factor. So, 1/4, not 1/2. So I'm going to take 1/4 and multiply by 1, 3, 5. So I'm going to get 1/4, 3/4, and 5/4. And if it's helpful as decimals, right, 0.25, 0.75, and 1.25. All right, so we are going to put our vertex at 0, 0. And then I'm going to go up 1/4 and over 1, so barely up. Then I'm going to go up 0.75, right, 3/4. So there's another 3/4 and over 1. Then I'm going to go up 1.25 and over 1. All right, so this one is fat. It's been vertically compressed by that scale factor, or that factor of 1/4. Okay, now we're going to write the equation of the parabola given some transformations. So it's reflected across the x-axis, vertically stretched by a factor of 6, and translated 3 units left. So let's start with any horizontal transformations because that goes inside the parentheses with the x. So we're going to say left 3 means I need to add 3, okay? A reflection across the x-axis means it's going to be a negative out in front, and it also has a vertical stretch factor of 6. So the negative and the 6 go together with reflection and stretching or compression. That's going to be one number. If it's reflected, it just becomes negative. Okay, vertically compressed by a factor of 1/3 and translated 2 units right, 4 units down. Okay, so 2 units right, that's our horizontal one, so we're going to subtract 2. The vertical compression goes in front of the parentheses being multiplied, and any vertical up or down is addition or subtraction outside the parentheses. So, and this is down, so we are subtracting 4. All right. Okay, guys, that is it for section 5.1.